Good day. So today we'll discuss discrete probability distribution, how to compute its mean, variance, and standard deviation, and solving word problems. So last time we've discussed a short review on probability, on how to get a probability of a given event. So now let's proceed with discrete probability distribution. So a discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities of the values. The probabilities are determined theoretically by observation. And take note, when we discuss about discrete, the data here are whole numbers or integer. Now, we have this random variable x. So a random variable x has the following properties. So the probability of this random variable x must be between 0 and 1 inclusive for all x. And the sum of its p of x sub i's must be equal to 1. And these x sub i's must be independent or mutually exclusive, I mean. So the listing is exhaustive, meaning all possible outcomes must be included. And the outcomes again are mutually exclusive, meaning the outcomes cannot occur at the same time. Say for example, when you toss a fair die, uh, it can only have 1, 2, 3, 4, 5, and 6, not 1 and 2 or 2 or 3 or any pair of numbers when you toss a single die. It can only give you either an outcome of 1, an outcome of 2, and so on. So this is a discrete probability distribution and with a property of random variable x. Now construct a probability distribution for rolling a die. So take note, a die has 6 faces. So it has 6 outcomes, 1, 2, 3, 4, 5, and 6. And of course, each outcome has a probability of what? 1 over 6. Because there is only 1, so we have 1 over 6. 1, 2, so 1 over 6. Only 1, 3, so 1 over 6. Only 1, 4, 1 over 6. Only 1, 5, so 1 over 6. And only 1, 6, so 1 over 6. Okay, to check whether this is a probability distribution, of course, we'll check the properties. The probabilities are all between 0 and 1 inclusive. So check. Of course, it's mutually exclusive. The outcomes cannot occur at the same time. We exhaust all the possible outcomes, the 1 to 6, we exhaust all of them. And also the sum of this 1 6 plus 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 1 6, this is equal to 6 over 6, or this is equal to 1. Okay, now let's proceed to example 2. Construct a probability distribution for tossing 3 coins. Let x represents the number of tails. So when 3 coins are tossed, the sample space is this one. So you may use a tree diagram. So say for example, we have a 1 for the first toss of the coin. We have 2 and we have third toss. Or the third coin, I mean it's the third coin. So the first coin of course has an outcome of either head or tail. The second coin also has a probability or has an outcome of head or tail. But we need to list down all the possible combinations. So we can draw a tree diagram. So HT, HT, head, tail. Again, the third coin has also 2 possible outcomes. So we have head, tail. head, tail. So we also have head, tail, head, tail. So for the possible outcomes, we have this H, H, H. So we have this H, H, H. Next, H, H, T. So we have H, H, T. H, T, H. So we have this. Then H, T, T. Where's H, T, T? So we have this. Then we have T, H, H. So we have T, H, H. We have T, H, T. T, H, T. T, T, H. We have this. And we have T, T, T. So thus we have this sample space. Now take note, our random variable here is x, which is the number of tails. So by observation, this has 0 tail. Remember, when we talk about random variable, we must assign a specific discrete number, okay, to x. So in this case, since we're talking about the number of tails, so we can assign this one without tail for 0 or a 0. This one, it has only one tail, so this is for 1. This has only one tail. This has only one tail. This is 2 tail. So we have 2 tails, we have 2 tails, and we have 3 tails. So therefore, we can assign our x variable x as 0, 1, 2, or 3. Okay, so 0, 1, 2, or 3. So if x is the random variable x for the number of tails, then x assumes this. So as what I've explained earlier. So 0, 1, 2, 3. So hence, we have this. So this is our x. So 0, 1, 2, 3. Now what is this? 1 over 8. Of course, we have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements or possible outcomes of this sample space. So for the 0, we only have 1 for this one. Only one uh, outcome with no 0, or with no tail. So we have 1 over 8. Now for 1, with having one tail, we have 1, 2, 3. That's why we have 3 over 8. Now this one, we have 2, 1, 2, 2, so we have 3. So we have 3. That's why we have 3 over 8. And last, we have 3 tails. So that is why we have only 1, having 3 tails. So therefore, this is now our probability distribution. Next, so a wallet containing 4 100 peso bills, 2 200 peso bills, 3 500 peso bills, and 1 1000 peso bill. Construct a probability distribution for the data. So let P of x be, or the probability P of x can be calculated for each x by dividing the number of particular bills by the total number of bills. Now, what is the total number of bills? So we have 4 100 peso bills plus 2. So we have 6 plus 3. So we have 9 plus 1. So there are 10 peso or bill, 10 peso bill in his or in this wallet. So we have 100 peso bill, 200 peso bill, 500 peso bill, and 1000 peso bill. So according to this, there are 4 100 peso bill, and there are 10 bills all in all. So we have 4 over 10. Next, there are 2 200 peso bills. So we have 2 over 10. And then there are 3 500 peso bills. So we have 3 over 10. And for the last one, we have only 1,000 peso bill. So we have 1 over 10. Okay, so you may write it in its decimal form, or you may write it in its simpler form or simplified form. Okay, now how do we compute for the mean, variance, and standard deviation? So we have these formulas. So the mean, of course, is denoted by mu, and this is the measure of central location. And the mean is always equated to the average. So the mean of a discrete random variable x is the weighted average of the possible values that the random variable can take. So this is the formula. In expansion, we have this. And this is also the formula for the expected value or expectation. For the variance and standard deviation, they are the measure of spread or dispersion. So it measures how far the data from each other or from the mean. Usually we use variance or standard deviation to determine whether the data are homogeneous or non-homogeneous. Non-homogeneous means heterogeneous. So a variance of 0 indicates that all of the data values are identical. All non-zero variances are positive. So take note, it can never be negative. So as well as with the standard deviation, it cannot be negative. Variance and standard deviation are always positive. Now, a small variance indicates that the data points tend to be very close to the mean or to each other. So meaning a small variance indicates that the data are homogeneous. If it's high, if the value of the variance is high, then of course they are far from each other, they are spread, so they are heterogeneous. So we have now the formula for the random variable. This is the either of the two. You may use either of the two formulas. So just for this one, just follow the PEMDAS or GEMDAS. And the formula for the standard deviation is just this. So if you have the answer of this one, you just take the positive square root. Okay, positive square root. So let's apply these formulas. So example 1. So 5 balls, numbers 1, 2, 3, 4, 5 are placed in a box. 1 is selected, its number is noted, and then it is replaced. So say for example, if in a box we have 1, 2, 3, 4, 5, and then 5 was drawn. So I've selected 5. After noting that I've selected 5, I will return the ball 5 inside the box. So that is with replacement. So by returning the ball inside the box. Now if this experiment is repeated many times, find the mean, variance, and standard deviation of the numbers on the ball. So in this case, we're not given with a probability distribution table, so we will provide or we will give the probability distribution table. Now this is the solution. So let x be the number of each ball. So that is our random variable x, the number of each ball. Take note that the ball selected is always replaced. So for all of these balls, the cardinality or the number of some of outcomes in the sample space is 5 because there are 5 balls. So the probability distribution is like this. 1 over 5 for all because there is only one ball, only one, 2 ball, only one, 3 ball, only one, 4 ball, and only one, 5 ball. That is why we have this. And if you may remember the properties, all of the 5 balls or possible outcomes are exhausted. Next, uh, the probability distribution or the probability of each is between 0 to 1. So all of them are 1/5. And of course, when you select, you only draw one. So you may not draw 2 or 3 balls. So it's mutually exclusive. And of course, the sum, 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 is 5 over 5, which is equal to 1. So the properties are satisfied. Now we proceed with the mean. Now if the properties is not satisfied, then of course do not compute for the mean because something is wrong with your probability distribution. To compute for the mean, standard deviation, and variance, in the first place, your probability distribution must be first correct. Okay? You must see to it that the table is correct or the probability distribution is correct. Now, the mean is this. This is the formula. So actually, if you have the table, it's easy. You just take the product of each of these column, take the product. So this one, we have 1 times 1/5, 2 times 1/5, 3 times 1/5, 4 times 1/5, 5 times 1/5. And then you sum up. You sum it up. You sum them up. So using your calculator, you will get 3. Okay, so the mean is 3. Now let's go to the variance. So I may use the first one, the first equation. So take note, 1 over 5 is 0.2. Okay, I think it's easier to input 0.2 or 0.20 than 1 over 5 on your calculator. So first we have this. We write this first. So we have 1 square, the x square times 0.20 plus 2 square times 0.20, 3 square times 0.20, 4 square times 0.20, then 5 square times 0.20. Okay? After that, on the other side, you subtract minus 3 square. The 3 is from here. The mean is 3. Okay? You may use your calculator in computing this one directly, or you may do it one by one. So this is 0.2. The result of this is 0.8. The result of this is 1.8. For this, we have 3.2. And for this, we have 5. Okay? And 3 square is 9. Using your calculator, we have 11 minus 9 or equals 2. So the standard deviation, therefore, is just the square root of 2, which is 1.41. So it means that the data are close to each other or close to the mean. Okay, example 2. Again, so with replacement, suppose an individual plays a gambling game where it is possible to lose 50, break even, win 150, or win 500 each time he plays. So we have now the probability distribution here. So we need to find the mean and variance. But of course, we can also find the standard deviation later by taking the square root. So we have lose 50, so that is negative 50. Break even, of course, that is 0. Win 150 and win 500. Break even means you did not lose and you did not win. That is why it's 0. So the probability of x are now given. So the table for this one is already given. So the mean is, again, you take the product of each column, product, and then you add. Okay, after adding, the result is 30. So the mean for this one is 30. So I think it means that on the average you will win at least 30. So now let's go to the variance. So again, I'll use the first formula. So square your x. So we have negative 50 square. Take note of the substitution. The negative is inside the square. So you have this times 0.35, 0 times 0.45, 150 square times 0.15, 500 times square times 0.05. Minus, again, the mean is 30. So 30 square. So using your calculator, the variance is 15,850. And if we take the square root, we have this. So the values, of course, the values of these two, variance and standard deviation, is very high. So if you notice, they are really far from each other. Unlike for this one, they are really near to each other. That is why the variance and standard deviations are small, unlike this one. Okay? So example 3, the RFS Electronic sells iPhones for Apple Incorporated. So they usually sell the number of iPhones on Sunday. So the store manager has established the following probability distribution. So this is on a particular Sunday. So the question is, how many iPhones should the store manager expect to sell? Another question is, what is the variance and standard deviation of the distribution? Now, the first question is for the expected value. So we may use the formula of the mean because they have the same formula. Okay, so we have this. Okay, so 0 times 0.05, again, we just take the product of each column, product of each column, and then you add. Okay, so the result is 3.51. Okay, so we can round this up to 4. Okay, so the store manager should expect to sell 4 iPhones on a Sunday. Now, how do we compute for the variance? So we may use the table, the second formula. So it's either you may use the table or a pure substitution on the formula. So we're given with this. This is the iPhones and the probability of px. So I just wrote this one in a vertical form. So in the formula, this is the main formula. The square of x minus mu times the probability of x. So by GEMDAS, of course, we will start with the grouping symbol. The grouping symbol is x minus mu. And then e exponent. So we'll then have the square. And then next is we will multiply this by the probability of x. That's why we have this. So x minus mu, we have this. So take note, our mu is 3.51. It's here, 3.51. And our x's are this. So 0 minus 3.51, 1 minus 3.51, and so on. So we have these values. Okay. After getting these values, you square each of these. Take note, this is always positive. Okay. Always take the square, so it's always positive. After this, you multiply these two. Okay, you multiply these two. The result of this one and this one. So that is for this column. Okay. Afterwards, you sum. You add all of this, and the answer is 2.48. So the variance is 2.48. So it's very small. Of course, we can see it here. So therefore, the standard deviation is just the square root of 2.4898. So which is equal to 1.5779. So it's very small. We can see it here. 0, 1, 2, 3, 4, 5. They are very near to each other. Example 4. The number of jackets sold per week at a boutique shop is shown in the table with the corresponding probabilities. Find the mean, variance, and standard deviation. If the manager of the boutique shop wants to be sure that he has enough jackets for the next month, how many should the manager expect to sell? Take note, this is per week. Okay? So this is per week. The table is per week. And we need to find for the whole month for the next month. So this is for the expected value or expected outcome. So again, we'll use the formula of the mean. So again, you compute for the product of each column, multiply, and then you add. The result is 16.94. So approximately 17 jackets in a week, because the table is in a week. Okay, the data for a week. So therefore, for a month, there are 4 weeks in a month. So we can multiply this. It's 17 times 4 is 68. So for the next month, the manager can order or can purchase at least 68 jackets for the next month. Okay, at least 68 jackets for the next month. Now for the standard deviation, so I will go back to the first formula. Okay, so we have this. And take note, it's lacking with, what is lacking? Minus 16.94 square. So we have, what is 16.94 square? So I will compute 16.94 square. So we have 286.9636. So if we complete this one, this thing is yellow, but it could also be white. So this is now approximately 4.4164. So this is the final answer for the variance, 4164. Now for this one, this is wrong. So this should be square root of 4.4164. And the square root of this is 2.1015. Okay, so 2.1015. So as expected, the variance and standard deviation is small because take note they are near to each other. They are not that far from each other. Okay, example 5. 500 raffle tickets are sold at 25 each for three prizes of 4,000, 2,500, and 1,000. So these are the prizes. After each prize drawing, the winner ticket is then returned to the collection of tickets. So this is with replacement. Okay, the winning ticket will be returned again in the prize drawing or in the collection of tickets. So what is the expected value if a person purchases 4 tickets? So expected value only, so we will only find the expectation by using the formula of the mean. Now take note, the cost in playing the game or the in buying the 4 tickets is 25 because that is 25 for each ticket. So 25 times 4 because 4 tickets are purchased. So 25 times 4 is 100. Now, because of this, the person's gain for the prizes will be subtract will have a subtraction of 100. Say for example, if you get 4,000, it does not mean that you gained 4,000, right? You did not gain 4,000 because you paid for 100 pesos for you to be in the raffle, join the raffle. Or so that is why, so 4,000 divided by 100, 4,000 minus 100 is 3,900. 2,500 minus 100 is 24. 1,000 minus 100 is 900. So these are now our possible gains, 39, 24, and 900. And of course, if you cannot get or if you cannot win these three, of course, your losing money is only 100 pesos. Why? Because you only paid 100 pesos. So your loss, if you will not win these three, or if you cannot win these three, is only 100. That is why we have negative here, because it's for loss. Okay? Now let's go to the probability. Why is it 4? 4 because you bought 4 tickets. Okay, and take note, in this particular problem, only one winner will win 4,000. Only one winner will win this one, and so one winner for each prizes or for each prize. So that is why the probability of winning this prize is only 4 over 500 because there are 500 tickets here, 500 raffle tickets, and you bought 4 tickets, so 4 over 500. As well as with this one, since the winning ticket are returned, so the same. So we have 4,500, and for 900 we also have 4 over 500. I mean 4 over 500. Okay. Now, what is the probability of the loss? Take note, recall that the sum of each probability must be equal to 1. Okay. So take note, in order for this to be 1, it should be 500 over 500 because our number of tickets or the denominator is 500. Okay, now to do this, so that the sum of these 4 columns are 500 or is 500 over 500, so we must subtract these 4, 4, and 4 from 500. Okay, so by doing this, we'll get 488 over 500. Okay, okay, so that when you add 488, when you add 488 plus this 3, 4 over 500, the result is equal to 500 over 500, which is equal to 1. So that the probability distribution of a random variable x must properties of that must be satisfied. Okay, so since there are 4 tickets, now the expected value is this. So this is now e of x, the same formula for the mean. Okay, so again, you just do this, take the product, take the product, take the product, take the product, and then you sum up. Okay, so the result is negative 40. So the person, or you will expect that the person will be on the negative side, so losing part. So on the average, you will lose negative 40. So it may give you an idea that you will somehow lose in the game. Now, example 6. Okay, the same type of problem, but this time the number of winners for each prizes is not only one. Okay, for 400,000 we have one prize only. For 150,000 we have 2 prizes. For 25,000 we have 4 prizes. In the previous example, only one winner for each prize. Okay, there are 50,000 tickets are sold at 50 each. So find the expectation if a person buys 25 tickets. So again, we'll construct a probability distribution. So take note, to play the game, so we have this 50 pesos or 50 is the price of each ticket, and you bought 25 tickets. So 50 times 25 is 1,250. Thus, again, the same with the previous problem. The person's gain for the prizes should be subtracted or should subtract 1,250 because you paid for 1,250. Thus, we have these 3 following gains. Okay, you will gain either of these 3. And for the loss, if you will not win or cannot win these 3, you will only get 1,000. You will only pay 1,050, so it's a loss for you. So that is why negative 1,250. Now for the probability, that is over 50,000 because there are 50,000 tickets sold. Okay. Now this one here is the number of winner. Okay, this 25 is the number of ticket you bought. So one winner times your ticket 25, so that's why we have these. For the second part, we have 2 because you have 2 chances because there are 2 prizes. Okay, so 2 times 25. For the 25,000 prize, there are 4 winners, so you have 4 chances. So multiply it to your 25 tickets. So you have now 4 times 25 chances. Okay, so this is 25, this is 50, and this is 100. Okay, the same with the previous example, we will subtract this 3 to 50,000, which is our denominator. So 50,000 minus 25 minus 50 and minus 100. So the result is 49,825. So our probability distribution now is complete. So we're now ready to compute for the expectation. So this is now E of X. Okay, so multiply, 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 and then you add. Take the sum. So the result is negative 850. So again, it's losing part for you. So on the average, you will lose negative, you will lose 850. Okay, so it means it will give you an idea that you will be on the losing part of the game. And last example, if a person rolls a pair of dice and gets a sum of 7 or 8, he wins 800. If the person gets 6 or 9, he wins 600 pesos. The cost to play a game, the game is 100. Find the expectation of the game. So this is the solution. So the same with the previous one, since the game cost 100 pesos, so we will subtract 100 from 800 and from 600. Okay, so 800 minus 100 is 700. 600 minus 100 is 500. Okay, and the loss, for the loss column, it's only 100 pesos because you paid 100 pesos to play the game. Now, how did we get this 11 over 36, 9 over 36? Take note that in tossing a pair of die, the possible outcomes, the number of possible outcomes is 36. We have 6 times 6. 6 for the first die, 6 outcomes for the second die. Okay, so there are 36 all in all. Now, for the first one, it's a sum of 7 or 8. So what are these? So we may have 2, 5, 5 and 2. Uh, okay. Then we have 2, 6. We also have 6, 2. So this is 7, this is 7, this is 8, this is 8. What else? We can have 4, 4, 4, 8. What else? We can have 3, 4, and 4, 3, 4, 7. We also have 5, 3, and 3, 5. So this is for 8. And also we have 1, 6, and 6, 1, 4, 7. So I think these are all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that is why we have 11 over 36. Now let's go to a sum of 6 or 9. Okay? So 6 we can have 2, 4, 4, 2, 1, 5, 5, 1. And we can also have 3 and 3. For 9, we can have 6, 3, 3, 6. We can also have 5 and 4, and 4 and 5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is why we have 9 over 36. So to complete this, for the last column, we have 36 minus 11 minus 9. So we have 16 over 36. So we're now ready to compute to solve for the expectation. So we have this. Okay, so using your calculator, this you will arrive with positive. That's positive 294.45. So in this kind of game, you may now have a chance of winning the game. Okay, so thank you for listening.